Hello, all of those who don't know why beta plus 1 is doing in the circuit, please pay attention. Okay? Hold on. We start out with this circuit. Okay? It's an amplifying stage. Now, in order to do the analysis of this loop, we need to first calculate the Thevenin equivalent and voltage equivalent. Thevenin voltage and Thevenin resistance, correct? Now, how do you calculate the Thevenin voltage, the Thevenin resistance? You start by shorting out the power supply. You short out the power supply, and when you do so, this point is the same as this one. So these two resistors are in parallel, right? So R Thevenin is going to be R1 plus R2 in parallel. That is going to be 39 times 3.9 over 39 plus 3.9. Okay? It's going to be 3.55K. That's R Thevenin.
Yeah, that one I get it.
Voltage Thevenin. Use the voltage divider rule.
Put the soft spot.
Right? Voltage divider rule for that point. It's going to be R2 times VCC over R1 plus R2. Substituting the values, it's going to be 3.9 times 22 volts divided by 39 plus 3.9. It's going to give us 2 volts at this point, right? Now remember, we want to calculate what's going on in this loop, right? Now, let's take a look at this formula. Current at the base is going to be the voltage Thevenin, which is, this is the equivalent circuit, which is the voltage Thevenin over, minus the voltage of the emitter base junction, which is 0.7 volts. Okay. Current is voltage divided by resistance, right? So up to this point, we're fine. R Thevenin plus RE. But now we see this beta plus 1. What the hell is this doing here? This beta plus 1. Okay? The answer is the following. The resistance of the emitter is part of the emitter collector circuit. Okay? But it's also part of the base circuit. So you have a common resistor for two different circuits. Now, what happens from the transistor point of view is that when you're looking at that resistor from this point of view, it's not going through the transistor. It has whatever value it has, right? But when you look at that resistor from this point of view, that goes through the transistor, this value is, remember this, is reflected back into this circuit by a factor of beta plus 1. So the resistance that you're looking at from here is this multiplied by beta plus 1. That's why this is here. And this is something you have to just know.
Oh, so it's common knowledge.
It's common knowledge. Okay? Then you do your calculation and you get the amps for the current at the base, which is 8.38 microamps. Okay? So current at the collector is beta plus IB. Now you can find your current at the collector. But the key point in this is voltage Thevenin, resistance Thevenin, and knowing this fact. Without this, I mean, you need to use this because you have to know it. Don't just plug in beta plus 1, without understanding what's going on. Current is equal to voltage over resistance.
Oh, now I.
Again, I'm going to go over this one more time. The resistance in that loop is going to be the resistance of the Thevenin equivalent plus the resistance of the meter. But it's the resistance of the meter that I'm looking at from that point of view and how it reflects back to that circuit. Is that clear? So that resistance of the meter, looking at that from the base point of view, is going to be this value. And this is something you have to believe in. Okay?
Now it make a lot of sense.
Like Dr. Q was said.
Now it makes sense.
As your
Right?
name.
Now it makes sense, right?
Yeah, now it makes sense to me because.
Okay.
Yeah.
Now, in order to understand this, you need to do your reading. I mean, this is just a formula. You have to understand. You have to do your reading. Spend your time reading the chapter. Okay? Because now